Here's Vinita talking about her life as a rocket woman. Enjoy.
Hello, everybody. My name is Vinita Marwaha Madill, and I'm a space engineer and founder of a platform called Rocket Women, which aims to empower young women to choose a career in STEM. And it's a pleasure to speak to you all today, and I am really excited to tell you about my career path in space and hopefully provide some really useful advice and inspiration along the way. Now, I wonder if any of you know who this is. Well, this is Helen Sharman, and she is the first British astronaut. Now, I want you to come with me to a library in 1993. And in that library, a 6-year-old girl sits reading in the children's section with a pile of books next to her. And for as long as she can remember, the 6-year-old girl has dreamt of going to space. She loves everything to do with space. She's meticulously found every single book that she can about space in the children's section and has them piled up next to her. And among the stories of space shuttle missions and NASA astronauts, in one of the pages of a book, she sees an image of a woman in a spacesuit with brown hair like her, and there's a British flag on the arm of the spacesuit. And the caption next to it said that this is Helen Sharman and she's the first British astronaut. And looking at that image, that girl realizes that her dreams are possible. And she knows what she wants to be. She wants to be an astronaut like Helen Sharman. And that 6-year-old girl was me. And I remember being that enthralled little girl in the library and learning that the first British astronaut, chemist Helen Sharman, beat 13,000 applicants and flew to the Mir space station. And she was, although I didn't know it yet, a role model to me. And she showed me at a young age that my dreams are possible. So I knew I wanted to be an astronaut, but what I didn't know was how. So a few years later, at the age of 11, I printed off the NASA astronaut guidelines from NASA's website and at the library, and I actually glued these to the inside cover of my secondary school folder, which is a bit geeky. And they were really a daily reminder of how to reach my goal, and I set my focus on achieving them. And those guidelines set the direction for my career. And the first guideline, as you can see, says that a candidate has to have a bachelor's degree in engineering, biology, physics, or maths. And so knowing this, I studied maths and physics at King's College London in the UK. I started the course, actually started off with a mixed course of young men and women. And in the end, only 3 women graduated from the course. One went on to be an astrophysicist, one is a science teacher, and I work in the space industry as well. And I think the rest of the cohort decided to do maths and management, so other degrees at King's along the way. But whilst I was at King's, I heard of this fantastic organisation called UK SEDS. They're the UK Students for the Exploration and Development of Space. And it was actually while I was at a conference by UK SEDS in Milton Keynes that I met space engineers and space operations engineers for the first time, including somebody that I actually went on to work with about 5 years later in Germany. So for me, being part of SEDS really allowed me to interact with professionals from the space agency and space companies. So at that point, rather than space being just a dream and something that I read about, suddenly it really felt attainable to me. So I've taken small steps over the last decade or so to work in the space industry and through secondary school before that as well. One of the largest of these steps was going to somewhere called the International Space University, or ISU, which was a life-changing experience. And it had daily astronauts, lectures by astronauts and space industry experts. And it was a 9-week interdisciplinary program, both intercultural and international as well, where you meet people from all around the world. So this is an example of the images here of a rocket competition, which is one of the activities that we did. And my team of a Canadian, an Italian, a Brazilian, and myself from the UK designed and built a model rocket and a parachute to launch an egg into the sky and safely land it back again. And we actually won the competition. So it was also really interesting activities like this and examples of teamwork and project work that kind of brought this international class together. And it was actually at ISU that I attended a workshop on spacesuit design led by a NASA engineer. You can see the image in the bottom left of the slide there. And it was through this workshop actually that I learned that I wanted to work on spacesuit design and operations in the future. And I wanted to work at NASA's Mission Control. So after this course, I made a decision to study astronautics and space engineering at Cranfield University, which is an in-depth engineering master's. And still remembering the astronaut guidelines, I decided to do an additional master's in business at ISU, this time in space management at their main campus in Strasbourg. And this really gave me complementary skills to a technical background and helped me understand why the decisions were really made in the space industry, and also I think in industries globally. So along with the project management and business development, product management, strategic planning. So the skills that really helped me to this day in my current role as well are really complementary to those technical skills that I learned in my previous education. And along this path, I had an amazing opportunity to live and work at NASA Ames Research Center in California for almost 4 months, where I taught physics to the students of the ISU Space Studies course that year, which was an incredibly rewarding experience. And being at NASA Ames truly was amazing. And I was able to see real life mission development and research and development, including something called a vertical motion simulator, which simulates aerospace vehicles, including the space shuttle, and is also used for astronaut training. But one of the most inspirational people that I met was the real life Ellie Arroway from the film Contact, and the lady on whose Jodie Foster's character was based, and that's Jill Tarter from SETI. And Jill led the project to build the Allen Telescope Array, which is a massive new instrument that will eventually comprise of 350 antennae, which are each 6 meters in diameter. And she's a woman with extreme passion for her subject, and she's impressively dedicated over 35 years of her life to the search for extraterrestrials as well, which is really amazing. So now considering the astronaut guidelines before, so I had a bachelor's degree in maths and physics with astrophysics, and I was working on 2 master's degrees because I was ambitious. But to be an astronaut, I still needed more experience. And so through the International Space University, I traveled to Russia at the time, not knowing that the project that I work on later on at the European Space Agency would mean that I'd actually work directly with colleagues from the Russian space industry and from the space agency. So on there, and especially with the Astronaut Training Center in Star City as well, that you can see here. And I actually worked on them on a regular basis and talked to them almost every day, specifically to develop the spacewalk training as well for the crew. So since that initial spark at the International Space University to work on spacesuit design and spacewalk training and operations, I hunted for a spacesuit project at the European Space Agency, and I found the skin suit project. And moreover, I persuaded them to let me work on it during an internship through the International Space University, again, as part of my master's. And I actually also completed a second internship at the Astronaut Center on spacesuit design and astronaut training and operations, this time for lunar exploration, which is really relevant today, and I'll talk about that a bit later. So in space, astronauts lose around 2 to 3% of their bone mass during 6-month missions to the space station. And they also grow around 4 to 6 centimeters taller, which can impact their spinal health as well. And that can also be quite painful for them. And for example, NASA astronaut Anne McClain grew about 5 centimeters in 3 months on board the space station. So we designed something called the skin suit that you can see in the left-hand side of the image here. And the skin suit is designed to be worn inside the spacecraft, and it provides loading to the astronaut's body that essentially recreates the effect of gravity upon the skeleton. And each skin suit is individually fitted to every astronaut, and a tailor takes around 150 measurements of the astronaut's body before they fly, along with measurements of their mass and also height, to customize a suit to each astronaut. And the skin suit has been worn on the space station by the Danish European Space Agency astronaut Andreas Mogensen, and most recently has been evaluated by the French ESA astronaut Thomas Pesquet, that you can see here on the image on the right during his 6-month mission, and he's actually wearing it on the space station here. And an example of the prototype is on the left there. And this is me with my mum at the European Astronaut Centre where she came to visit, and that's the prototype of the suit that I was working on. And it's been really amazing to have worked on the initial prototypes of the spacesuit, and actually having seen it being worn on the International Space Station as well by astronauts is really the ultimate reward, I think. So from working on spacesuits, I moved to space station operations at the German Aerospace Center, or DLR, and my typical day there involves supporting astronauts on board the space station to carry out experiments successfully, to developing new experiment payloads with scientists, or even helping to train astronauts on those payloads, those experiments and equipment that they use on the space station. And also writing the crew or astronaut procedures was something that I really enjoyed while I was working there. And I think the most important skills for a space station operations engineer are communication, so both on console and mission control, and also with your international colleagues based around the world, because there are mission control centers not only in Europe, but also in the US, in Japan, in Russia, and in Canada as well. So in all of the member states of the space station as well, of the countries that work on the space station. And so I was just working with one of the partners of the space station. And more specifically, I think you need to have the ability to think quickly to provide an accurate response in case of anomaly on the space station, and also be prepared as well, is also probably a good piece of advice. So after spending some time actually working in Canada for a tech company after that, I went back to Europe to work at the European Space Agency again, but this time as a contractor, and at ESA's technology center in the Netherlands called ESTEC. And there I focused on operations for a future human spaceflight project, including the European Robotic Arm, or ERA. And ERA is a new robotic arm that's due to be launched to the space station this year, which is really exciting. And it's going to help astronauts and cosmonauts carry out spacewalks on the space station, and also help to install new parts of the space station as well. So at ESTEC, I helped to develop a smaller version of mission control at ESA Technology Center in the Netherlands. And also worked on cosmonaut and crew instructor training, or astronaut training as well. And the instructors as well need to be trained that go on to actually train the crew in Russia, specifically related to spacewalks, which was incredible. And an image on the right that you can see is Samantha Cristoforetti, the European Space Agency Italian astronaut, actually being trained to use the spacewalk or EVA control interface for the robotic arm. So the astronauts can control the robotic arm from predefined missions that we test on the ground. So they control it from onboard the space station, so either inside the space station, or they can control it while they're doing a spacewalk as well through a special interface that you can see there. And now I'm based in Canada at Mission Control in Ottawa, which is a space exploration and robotics company with a focus on mission operations, onboard autonomy, and AI. And we're developing innovative solutions using space technology to solve the world's problems and explore space using software that we designed for space activities, from everything from lunar exploration to astronaut support systems as well. So I'm really lucky to be able to work on an extreme breadth of activities as well. And one of the projects that I'm leading is Mission Control Intelligence. And that's basically in partnership with a company in India to demonstrate AI-powered levels of autonomy on a micro rover ahead of commercial missions to the moon. And it's a cutting edge suite of technologies that will really enable mission operators to make key decisions in science and navigation operations faster and with more confidence. And we're also going to be developing and conducting a series of tests in our high-fidelity lunar analog terrain at Mission Control in Ottawa this summer, which is exciting as well, with the rover from the Indian organization that we're working with. So the future of space exploration is really exciting, and I'm looking forward to contributing to NASA's Artemis program as well, which aims to send the next man and the first woman to the moon as early as 2024. And the Lunar Gateway that you can see here is part of this, and it's currently being designed by the European Space Agency in conjunction with international partner agencies, so with NASA, JAXA, the Japanese Space Agency, and the Canadian Space Agency, to enable humanity to return to the vicinity of the moon in the 2020s, and building on the international cooperation that built the International Space Station as well. So the spaceship was going to be humanity's next step beyond low Earth orbit, and it's actually 1,000 times farther out into the solar system than the International Space Station as well. And its location here in the lunar vicinity outside of Earth's deep gravity well allows it to be used as a staging post for exploration missions to the lunar surface, and eventually to also other deep space destinations as well, including Mars. So it's a platform where we're going to learn about how to overcome the technological challenges of living and working in deep space as well, which are very different to working on the space station, and also prepare humanity to eventually travel to Mars. So lots of really exciting things to look forward to. But as I was going along my career journey, I noticed that over the years, as I progressed to each step, the number of women that actually progressed with me to ultimately choose a career in engineering decreased. And that's something called the leaky pipeline syndrome. And if you actually look at the numbers, in the UK, around 12% of the engineering workforce is female. And according to recent research from the Royal Academy of Engineering, around 9% of the engineering professionals are from Black, Asian, and minority ethnic backgrounds as well, compared to around over 12% of the UK population. So my passion and the goal of Rocket Women and our team is to work and reverse this trend through empowering young women globally to consider a career in STEM, but also supporting them throughout this career journey as well. And I think we really believe that seeing someone that looks like you both shows you and allows you to believe that it's really possible to achieve your goal as well in the future. And it's really important that we change these statistics that I mentioned as well, because we need to inspire the next generation and look to the future. Firstly, because there's a massive skill requirement for engineering coming up over the next few years. So at Rocket Women, we believe that the lack of gender and racial diversity in STEM, including the space sector, is not only an issue of inequality, but also affects the engineering that we do and the systems that we create as well. And we really need to enable engineering as a profession to reflect more of society and to prevent these unconscious biases as well from being implemented into the design and the applications that we develop. So everything from developing new spacesuits for the lunar surface to AI and novel facial recognition algorithms as well, I think really need to ensure that the creators and developers of these systems represent the range of backgrounds, cultures, and also experiences of the diverse users to prevent these biases from being incorporated as well. So I think now more than ever before, we really need 100% of the talent available to solve these really hard problems that we're facing in the world today, especially. And I think representation really matters as well. And scholarships play a pivotal role in encouraging diverse, talented individuals to pursue these opportunities in the space industry, but also in the tech industry as well. And I think they play a role to support this and to help these individuals from getting into the industry that may have not had that chance otherwise as well without that support. So through Rocket Women, proceeds from our apparel are going towards a scholarship for women internationally who choose to study engineering and science. And our scholarship was actually really born from a desire to make a difference. And I personally certainly wouldn't have been able to study and live internationally without the support of multiple scholarships as well. So it's a way for us to really make a difference to the future. And Rocket Women and myself have been really fortunate to work on this goal through being involved with campaigns, including a campaign to emphasize the importance of education with Canadian Prime Minister Trudeau's office and also Instagram. And this included a roundtable discussion with Instagram COO Martin Levine and also Prime Minister Trudeau as well, which was an incredible experience. We're very fortunate to have been involved in that as well. We've also developed an educational space activity book with Curved House Kids, which is a UK publisher as well. So we've got lots of really interesting activities and projects that we're involved in right now. So we really need to change this, as I mentioned as well. And I think one of the ways that we can empower women to become Rocket Women is, firstly, you can't be what you can't see. So during my career, I've met some amazing people, especially other positive female role models. And I think you need those role models out there, tangible and visible, to be able to inspire the next generation to become astronauts or be whatever they want to be. And I realized that the achievements of these incredible women wasn't being shared. And one of the main reasons that I started Rocket Women to provide a platform was to spread their advice and ensure these voices were being heard. And this quote by Sally Ride, the first American woman in space, really sums up the importance of this. And I quote, she said that I never went into physics or the astronaut comps to become a role model, but after my first flight, it became clear to me that I was one. And I began to understand the importance of that to people. I think young women and young girls need to see role models in whatever careers that they choose, just so they can picture themselves doing those jobs someday. You can't be what you can't see. This is one of my favorite quotes, and I think it's absolutely true. I think when you're younger, especially, you really need to see yourself carrying out that role in STEM in the future. And I think they're not only important as you start your career, but role models are really crucial throughout your career journey as well, from whether you decide to apply for that promotion that you have most of the qualifications for, but not all. I think you should always apply for it. Or even seeing someone that reflects you in a leadership position in your industry or company as well. I think role models are essential to provide you with examples to look up to when you're making these really critical decisions in your career. And one of the things that we're also aiming to do through Rocket Women, and I think is really important, is to change the stereotype of engineering and also of science and technology. And a great example is the Royal Academy of Engineering Sisters Engineering campaign in the UK that I'm really thrilled to be involved with. And the campaign celebrates the engineers shaping our lives and the world around us to really challenge these narrow public stereotypes of engineering. and aim to encourage more young people from all backgrounds to consider engineering as a profession. And engineering really is everywhere. So from everything from the heart of your mobile phone to satellites, to the special effects in your favorite sci-fi show, I think. But there's definitely a narrow and outdated stereotype of engineering, of what engineers do, what they look like, and even the role they play in society as well. And that can in turn prevent young people from considering these rewarding and varied careers, but also prevent us from kind of retaining this talent as well in the industry. And I really encourage all of you to go out and really communicate the work that you do. I think the tech industry is becoming increasingly diverse every day, and we really need all of us to work together and help to change the stereotype of engineering and tech as well. So what barriers are there to a career in STEM? I think there seems to be a disconnect between young women in particular wanting to make a difference and knowing the impact that they can make on the world and that positive impact they can make through a career in STEM. And I think separate from that, there are also cultural barriers that we need to overcome. So my background is British Asian. My parents are originally, and my grandparents are from India. So although my parents are really supportive of my interest in space and in science when I was younger, I think there was still some pressure to study a traditional subject for a girl in that culture. So become a dentist or a doctor or a pharmacist or a teacher, which are all really great professions. And they're considered, I guess, a safe choice or an acceptable job for a girl in a South Asian culture. But I know they weren't the right choice for me myself. And I actually worked as a dental nurse on the weekends while studying at sixth form, and it helped my parents. And I realized, although I really enjoyed some aspects of that job, and the medical side and be able to interact with patients as well, being a dentist wasn't for me in the future. But actually being based at the European Space Agency, I think many years later as a contractor, I actually worked on some of the medical aspects of preparing a launch campaign. So where the technical team go to a launch site, which in this case was in Kazakhstan, in Baikonur, to prepare the European robotic arm for launch for the mission that I worked on previously. And I've also worked in the European Space Agency Space Medicine Office as well. So I think having some background in medicine and the medical aspects of this have really helped. But I think ultimately we need to address the lack of representation of Black, Asian, and minority ethnic women in STEM and ensure that their stories are really visible and able to inspire and support both the future career decisions that women make, and also provide their peers with examples of successful careers. So through Rocket Women, we're aiming to ensure these stories of diverse women of STEM globally are visible. And I think also it's good to remember that you don't need to be the best in maths or science or engineering to work in STEM. You don't have to be number one or number two. And as David Newman, the former NASA deputy administrator, said, you just have to want to help humankind. That should be the passion. You don't have to be the best, just be proficient. And we need to change the conversation to know that you're all in as well. So what if you don't want to study science or engineering, but you still want to work in the tech industry? Well, there are lots of opportunities for you. I'm sure that many of you know. There are lots of different pathways to work in the industry. So during a Rocket Women interview with Emma Leinhart from NASA, she rightly mentioned that although we need more female STEM graduates, we also need, in her word, more policy wonks, as she said, more accountants, we need more lawyers, we need more artists and English majors. And I think really importantly, we need people who can really effectively communicate the really important work that we all do. And so she discussed that there was a woman that really had an impact on her when she was an intern initially at NASA. And that her name was Lynn Klein. And she only had one meeting with her, but she was absolutely struck that a French literature scholar became the deputy associate administrator for space operations at NASA as well. So I think relatedly, career progression doesn't necessarily need to be linear. Sometimes it might help to take on new responsibilities or learn new things that you're interested in. So even if you don't immediately see a connection to your job, or even if the upcoming promotion is that you believe is a next step forward as well, those transferable skills that you learn might actually be the advantage that actually drives you forward as well. So as NASA deputy administrator, the former NASA deputy administrator, David Newman, who I've heavily quoted throughout this talk because she is incredible. She says, you can zig and zag, but you don't need to all figure it out as well, which is also some great advice. So know you belong is the statement that I really want to get across here. So women have been a crucial part of humanity's race to explore space. So recently, the story of these amazing women, including the late mathematical genius Katherine Johnson, has been commemorated in a movie titled Hidden Figures. And Katherine played a role in every major US space program, from calculating the trajectory for Alan Shepard, who was the first American in space, his inaugural flight, to even the space shuttle era as well. And she calculated the trajectory for the 1969 Apollo 11 flight to the moon and Apollo 13. And when Apollo 13's mission was aborted, as many of you may have heard about, and she helped to safely return the crew to Earth 4 days later through her work on the backup procedures and charts. And in the words of former NASA Deputy Administrator, again, David Newman, Katherine literally wrote the textbook on rocket science. She says, "We are also fortunate that Katherine insisted on asking questions and on relentlessly pursuing the answers. We are so fortunate that when faced with adversity of racial and gender barriers, she found the courage to say, 'Tell them I'm coming.'" So Katherine Johnson initially wasn't made to feel welcome in that room, but she knew that she belonged there. So I'd recommend that we all channel our inner Katherine Johnson and find that power. So know that you belong in the room to get the work done and that they need you. And similarly, an example is by Ellen Stofan, and she is the director of the National Air and Space Museum in Washington, D.C. in the US, and she's a former NASA chief scientist. And she said that sometimes I felt that like I was part of the team until someone said something that made me realize I was a woman. But as I got more confident, I realized that they really need me in this room. Be good enough. So I want to tell you a story about Doug Hurley and Karen Nyberg. So these are both NASA astronauts, and they're both married, and they are parents as well to a young son. So Doug Hurley was actually recently one of the 2 astronauts on the historic NASA SpaceX Crew Dragon flight to the International Space Station. And this was the first launch from American soil for almost a decade after the space shuttle era as well. And Karen, as you can see here, has actually flown multiple missions to space herself, and has about 180 days in space between those missions. So here is Karen with her husband Doug and their young son Jack. And before one of the missions that Karen launched on, in discussing how becoming a parent had changed her during a media interview just before her 6-month spaceflight mission to the International Space Station, NASA astronaut Karen Nyberg said that she worked very hard to excel at everything that she had to do and had never accepted good enough during this. But since she'd become a mum to a then 3-year-old, in order to balance her life with her family and her job, there are some things that she needed to accept good enough on, which she said were okay. So she learned to do that and to work at that level, but she still tried to excel in most things that she does as an astronaut and also at home. But there are a couple of things that in order to just spend the time at home with her husband and her son Jack, she really needed to accept good enough on just a few things. So I think it's some great advice as well. So know which balls you're juggling are glass and which are plastic. So some great advice that I have certainly used is from Professor, author, and mum Nora Roberts, and highlighted on Twitter recently by Jennifer Lynn Barnes. And it discusses the key to really juggling kids and work, and is to know that some of the balls that you have in the air and you're juggling all the time are made of plastic and some are made of glass. And the main takeaway here is that if you drop a plastic ball, that's okay because it'll bounce back and there is no harm done. But if you drop a glass ball, it'll shatter. So you need to know which of the balls are glass and which are plastic and prioritize catching those glass ones as well. So glass balls, for example, might be picking the kids up from school or nursery or ensuring that you meet that really critical project deadline. Those are the ones you need to prioritize. But the plastic balls might be remembering that it's PJ day at nursery, or making sure that you do laundry every day, or getting caught up with your email inbox to just make sure that you complete all of those emails. So glass balls might be related to family, or another day those glass balls might be related to work as well. It's not really about prioritizing either work or family, but really understanding those priorities and which have the most glass balls will definitely change every day as well. So, and also sometimes to catch the glass balls before they hit the floor, you have to let go of the plastic balls. And some will shatter and some will bounce, and that's okay, but you need to know which ones are which. So the next point that I wanted to mention is get to the starting line. So after launching on both NASA's space shuttle and then the Russian Soyuz rocket, NASA astronaut Sunita Williams will be one of the first female NASA astronauts to fly to the International Space Station on board the new US commercial vehicles being developed, and she's going to fly on a Boeing vehicle. And Sunita actually formerly held the record for the longest spacewalk time by a female astronaut, which is really impressive. She also completed a triathlon in space and was a second female commander of the International Space Station as well. And she said that understanding how things work and being an engineer led me to become a helicopter pilot and eventually to NASA. So she says the path doesn't necessarily have to be straight, but don't limit yourself to what you know. Go out and try new things. Some of those things when I was young, I would have considered failure, but you just need to get to the starting line, which is some good advice as well. So in summary, you can't be what you can't see. Change a stereotype. Know which balls are juggling are plastic and which are glass. Know you belong and get to the starting line as well, as I mentioned. So things in the tech industry and the space industry are changing. The 2030 NASA astronaut class is actually 50% female, which is the highest ratio of women selected. And that brings a percentage of female NASA astronauts in the NASA astronaut corps to almost 30%. And this is 30 years after Sally Ride became the first American woman in space. So NASA's really looking forward, which is fantastic. And the first all-women spacewalk actually took place in 2019, which is about 50 years after the first ever spacewalk took place in 1965. But in 2019, history was made as NASA astronauts Jessica Meir and Christina Koch ventured outside of the Quest airlock on the International Space Station and carried out the first all-women spacewalk as well, which is a feat long overdue. And Soviet cosmonaut Svetlana Savitskaya actually became the first woman to carry out a spacewalk on 20th of July, 1984, around 35 years ago now. And of the more than 500 people who have been to space, around 10% have been female as well. So there's a lot of work we need to do there. And until 2019, spacewalk teams, of which there are usually two, have either been all male or male-female, with 15 women having carried out a spacewalk or extravehicular activity, as they say in the industry. And for example, there have been 213 male spacewalkers as well. So I think there's a lot of work we need to do there to make sure that there are more women that are able to carry out a spacewalk and actually in the NASA astronaut corps. But things are changing, and the most recent 2017 astronaut class had 5 girls out of a total of 12 astronauts, with 2 astronauts actually selected at 29 years old. So if you think about it, that's close to 10 years between completing year 13 at secondary school to being selected as an astronaut as well, which is pretty neat. So Zena Caldman at 29 didn't know if she had enough experience to be an astronaut to meet the bare minimum NASA astronaut requirements. But while she was studying for her doctorate, she applied anyway and became an astronaut out of 18,000 applications made. She said, "I've got nothing to lose. This will be a really cool experience no matter what." So Zena prioritized her passion and she persevered. This is an image of her here. And the last story that I want to tell you is about Anima Patel Sabale. So Anima grew up in India and she faced criticism when she would tell people that she wanted to become an astronaut. And her only inspiration at the time was India's only astronaut at that time, who's called Rakesh Sharma. And so growing up, she wanted to be a fighter pilot like him, and then become an astronaut. And even though India wasn't actually accepting fighter pilots yet, so there weren't any female fighter pilots at the moment, she was hopeful that things would change by the time that she graduated. So to become a fighter pilot, she had to study engineering or physics, and she actually grew up in a traditional household. So her dad said that she had to actually study near home. So she studied physics and she applied to be a fighter pilot, even though it said that only males can apply. But she was refused on the criteria that she was short-sighted and they needed perfect 20/20 vision. But on the back of that, she actually went on to fight for an education as well. As her father said that she shouldn't do a 3-year program as there were marriage proposals coming for her. And he couldn't guarantee if she could complete her degree if he found a boy suitable for her and decided to get her married. But she persevered, and her mum supported her by telling her dad that she was smart and she was ambitious, and to let her study, and that they can negotiate with her in-laws and her husband and to allow her to complete her studies. Well, thanks to her mum, Anima got her to complete her degree, and she worked to rewrite Indian traditions, especially in her household, and moved to the US, completed 2 master's degrees, and now works at NASA Johnson Space Center in Houston as an Orion spacecraft simulations lab manager. So she supports humanity's request to return to the moon. And she also gets up at 4 a.m. every day to both care for her family and also prioritize her passion as well, which is pretty impressive. But I do hope she gets to sleep on the weekends. So to work in technology or even be an astronaut, you need to study something that you love and that you're passionate about. And also really enjoy what you're doing and the work that you're doing. So some really good advice, I think, is to pay attention to what your passion is for. So in summary, you can't be what you can't see. Change your stereotype. Know you belong. Know which balls you're juggling, a glass and which are plastic. Get to the starting line. Prioritize your passion and persevere. So inspired by the incredible endeavors and journeys of persistence and determination of the rocket women of today, these are the tenets that I believe will help to encourage and empower women in the industry today. So coming back to NASA astronaut requirements and Helen Sharman. So for me, on seeing Helen Sharman in the library book at a young age, she really became a role model to me. And knowing that I had been a British female astronaut really helped me push through any negativity around my chosen career path when I was younger. So I knew that I wanted to be an astronaut or at least work in human spaceflight, and eventually I did. But I wouldn't have had that impetus and drive if I hadn't known that somebody had come before me. There had been a female British astronaut, and maybe there could be again. So I knew that it was possible. And through featuring advice and stories of women in science, engineering, and technology, I want Rocket Women to give other women that same realization that they can have a career in STEM and achieve their dreams. And we can improve the current percentage of female engineering talent to give every woman the chance to reach their potential and change the world through science and technology as well. So we really need 100% of the talent available to reach the stars and also solve the really hard problems that we're facing in the world today. So from making the next crucial scientific breakthroughs in vaccines to even landing on Mars as well, which we've seen recently. So I leave you with this great advice from Kirsty Duncan, who's a Canadian MP, and she said, dream your greatest dream and know anything is possible. Thank you very much for your attention, and please feel free to get in touch. My email is there on the screen and our social media accounts as well. So happy to answer any questions or any comments. Thank you for having me today.